Now I'll show you another example. This is a case study done with opposite technologies, using SLAM, and probably done badly on purpose. We've pushed things a bit to debunk those who are obsessed with extreme precision and think surveys can only be done with instruments costing 30 to 40,000 euros. First, a brief aside. ARCHLine.XP now loads multiple clouds, and there is a parameter called geolocation. So if the cloud has it, it is loaded and already positioned correctly. If not, with standard move, rotate, copy functions, you position it manually. In this case, we have interior and exterior clouds. A quick walk outside and then another cloud for the interior. It's a cloud. I forget exactly, but around 9 million points altogether for the entire project you saw. So it is extremely light, almost a bit provocative, and yet I wanted to show what really changes in practice. Here we are inside the cloud. We can still navigate it. We start to see the typical streaks of SLAM surveys, especially when we are not very careful or walk too quickly. Yet we can still interpret and understand that this is a survey of a 100 square meter apartment on 2 floors. What matters to us is being able to trace measurements in a fast, convenient way. The slice you see here in the section is much thicker. This might be a 2 to 3 centimeter slice, but what do I care? I still place my point roughly in the middle, so the maximum error I make is 1 centimeter. Is a 1 centimeter error acceptable? If it is, then this technology is more than good enough. We wanted to restitute and show just a small hint. This was a file we worked on. Starting from this cloud, we developed the entire model and all drawings. We must draw attention to where the efficiency gains lie when using a system like ARCHLine.XP. It's a design program, so working together with the cloud being the basis of my survey, I produce all the details, sections, elevations, schedules. If I need a quantity takeoff, I extract volumes and areas. If I need to lay out drawings, I produce the drawings. So we must understand that moving to this type of technology is not just about having a tool that produces 2 drawings from a cloud, but a complete design system that, over time, can make a real difference. So this was a small focus we wanted to present. I have 2 more things to tell you that I think you'll appreciate. Going back to the initial example and the use of 2D. 2D is not just drawing, it is modeling. We know that in ARCHLine.XP we can model slabs, we can modify profiles and so on. Let's look at this usage scenario. We're in the previous example with our model of a historic building. It's a fairly irregular building, not extremely, but with non-regular shapes inside, especially in the slabs. This is its section with its slice. We'll recolor it to see it better and create a red-colored section. So we have a clearly defined section, and I always like seeing 3D plus section together, which helps me understand what I'm working on. If I understand, I can work well. Just as with plan, I can move the section forward and backward. Watch this concept too. I'm in a section view and I move forward and backward. Notice on the left those arches. That's not the stairwell as a simple void. It's a 2-flight staircase. I move back and forth and examine my entire project this way. Not by navigating the cloud, but by seeing already comprehensible technical drawings. Now, to show an example, we'll focus on the ground floor where there is a vaulted slab, theoretically a cloister vault, but we'll simplify for this session and pretend it's a barrel vault. So a barrel vault, I'll draw a small piece of slab and show you how I model and verify it directly in the modeling environment. A barrel slab would actually be quite simple. If it were a cloister vault, I'd need to generate multiple views to get a real perception of the vault's section profile. Here, I work directly on it. I draw the slab, then modify it. I assign a thickness, say 1.5 meters, to cover the whole geometry, and then modify the profile, using those editing functionalities for which ARCHLine.XP is quite well known, directly over the cloud. We'll turn snap-on in this case because someone always likes seeing it, so I draw pick points. That's interesting and it can be impressive, but if we look at the immediately following step, that's where the real difference lies. Look, I'm in 3D, I see the section, and I can dynamically move it, so I can check whether what I've modeled is consistent. I don't have that if I rely only on a 2D section. I create it at a point, declare it good, and that's it. So with a small extra effort in adopting this system, the advantages are, I think, quite evident. But I still want a pure 2D view. Copy-paste, and this is new too, and I think many will like it. Copy-paste. I place myself in a 2D environment. I can produce as many of these as I want for free. I position the section where I want it and generate it. This is a 2D points drawing. If I want, I can redraw over it. Save it as DWG, redraw on top, turn it into images, whatever I need. This then connects with many other systems. This is a small extra feature we built. Line recognition. We're talking about 2D, but since some people like this, I draw a line, and as I move the mouse away, I'm not directly over the line, I'm at an angle. You saw the program recognize the direction. Now I'll exaggerate it even more. What does this mean? It means that by clicking approximately, without needing insane precision in snapping, the program automatically restitutes the pieces of line that are aligned with coplanar points it finds. Whether there is little or much noise doesn't matter, it compensates, and then I connect. The search for corner vertices I always do via intersection of sides I've already defined. Let me turn it off for a moment and you see what I was setting up. So we have an intelligent 2D from which other commands derive. Now we have commands for detecting slabs, columns, doors, windows. There is also one for irregular walls, which is a derivation. It's the last thing I'll show you, then I'll let you go. With the same technology, I define 2 lines, 2 skewed lines, and the program creates a non-regular wall, that is a wall with variable thickness.